All right, welcome to your lesson today. What we're going to talk about today is rate of change. I abbreviated that ROC, and slope. So rate of change and slope are the same thing, and you'll see how they connect in a little bit. So let's just jump in and try a couple of examples. It says find the constant rate of change between the quantities in each table. So first off, think of each table as being represented by two different things. Here we have items and cost. Whenever you have two different items or quantities in a problem, we represent them typically by X and Y. So X will always come first, just like in our coordinate. Y comes second. So rate of change is going to be your change in Y so your change in your Y value divided by your change in your X value. Okay, so again, rate of change is your change in your Y value divided by your change in your X value. So let's first check out what our rate of change is for Y. So to get from 12 to 24, we add 12. To get from 24 to 36, we add 12. And to get from 36 to 48, we add 12. So our change in Y is 12. That goes on top. Now our change in X, you can probably pretty easily see that we go up by 5s each time. 5, 10, 15, 20. So we're adding 5. We're going up by 5. So our change in X is 5. So our change in Y is 12. That goes on top. Our changes in X is 5. That goes on the bottom. So that's our rate of change. 12 over 5. Our change in Y is 12. Our change in X is 5. Okay, let's try another one. Here, I've got my time, which is representative of my X. Remember, X comes first. This is just a table that is flipped. Instead of going from top to bottom, it is going from left to right. So our X is on the top, our Y is on the bottom. So remember, rate of change is your change in Y over change in X. So let's first check our change in Y. We go from 160 to 120. Now, to get from 160 to 120, we're subtracting away 40, or that's a negative 40. To get from 120 to 80, again, we're subtracting 40. To get to 80 from 120, you take 120 minus 40, you get 80. So we're subtracting 40. And lastly, to get from 80 to 40, we subtract 40 again. So our change in Y is negative 40. That's on top. Now our change in X, we go from 4 to 6 to 8 to 10. So it's pretty easy to see that we're adding 2 each time. So our change in X is positive 2. Now, this is not going to be counted as completely finished because we can simplify this fraction. So I know that 40 divided by 2 is 20 over 1, or just negative 20. So again, 40 divided by 2 is 20, and I have that negative, so I have to keep that on my final answer. So my rate of change is negative 20. All right, the last one we're going to try that is a problem similar to this is going to be a table where our X is days and our money is Y. Okay, so to get from 100 to 80, we subtract 20 from 100 to get to 80. We subtract 20 from 80 to get to 60. And again, we subtract 20 from 60 to get to 40. Now, for our days, we go up by 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. So our rate of change is our change in y, which is negative 20 each time, over our change in x, which is a positive 1. And we can simplify that to negative 20. Now, whenever you have a constant rate of change, if you were to graph these points on a graph, these would make a completely straight line. This is called a linear relationship when you have a constant rate of change, or when your rate of change stays the same for your y's and your x's. All right, now I'm going to show you how to find your rate of change or slope from points that are not in a table but are given to you on a graph. Okay, so as you can see, we have a line, and that line goes through 2 points. And we're given those points, negative 2, 2, and negative 5, negative 3. So I'm going to put these 2 points into my XY chart so I can find my rate of change or my slope. Remember, they're the same. And my slope is my change in y over change in x. So when I go from left to right, the first point I see is negative 5, negative 3, and then I have negative 2, comma 2. And again, I pulled these points from my graph, and these points are going to give me the rate of change or the slope for that line given. So I'm going to first find my change in y, which is negative 3 to positive 2. Now, to get from negative 3 to positive 2, I go up 5. If I count that off in my head, to get from negative 3 to positive 2, starting at negative 3, I go to negative 2, negative 1, 0, 1, 2. So that is plus 5. So my change in y is 5. Now my change in x, to get from negative 5 to negative 2, I'm going to go up 3. So that's a positive 3. So my change in y is 5, and my change in x is 3. So that's my rate of change, or my slope. Now, there is another method to do this if you don't want to draw an XY chart. This is what you will be doing mainly in algebra next year, and I'll show you what you're going to do. So if you don't want to draw or use an XY chart, you can use the formula y2 minus y1 over x2 minus x1. And all this really means is that you're finding your change in y, and remember, to find the change in something, you have to subtract, and then you're finding your change in your x, or you're subtracting your 2 x's. So I'll show you how to do this for this problem. So my first coordinate again was negative 5, negative 3. And my second coordinate is negative 2, positive 2. So this is method 1, where we use XY chart. This is method 2 that you'll do in Algebra 1 next year. So my 2 y's in my coordinates are negative 3 and positive 2. My first y is negative 3. My second y is 2. So I'm going to subtract 2 minus negative 3. So that's my y2 minus y1, or my second y minus the first y. Now I'm going to subtract my x's. So my first x is negative 5. My second x is negative 2. So x2 minus x1 is my second x minus my first x, or negative 2 minus negative 5. Now at this point, I can just solve out this problem. Oops, there we go. So remember that when I'm subtracting, that's the same as adding the opposite. So I'm going to keep my 2, change my minus to plus, and flip my negative to positive 3. So I have 2 plus 3, which is 5. On my denominator, keep, change, flip, -2 plus a +5. -2 plus 5 is 3, or 5/3. So as you can see, I got the same answer for my table as I did using the formula of y2 minus y1 over x2 minus x1. You can choose whichever one makes sense to you. All right, our last example for today. So again, we have a line that goes through 2 points, and again, I'll show you both methods. So I'm trying to find my rate of change, or my change in y over change in x. So my first method, I'm going to put these in an XY chart. My first point is 0, 0. My second point is 2, -4. Okay, so to get from 0 to -4, I go down 4. So 0 minus 4 is -4. To get from 0 to +2, I add 2. So my change in y over change in x is going to be -4, that's my change in y, over x, which is a +2. And I can just simplify that to -2. Now let's do method number 2. So method number 2 uses the formula where I subtract my y's to find my change in y, and I subtract my x's to find my change in x. So my first point is 0, 0, and my second point is 2, -4. So the first thing I'm going to do is find the change in y, so -4 minus 0. That's my change in y. My change in x, I'm going to subtract my x's, so 2 minus 0. When I subtract, I find the change in something. So -4 minus 0 is -4, and 2 minus 0 is 2. And -4 divided by 2 is -2. So as you can see, my rate of change, or my slope, is -2. I got the same answer, I just used 2 different methods. You can pick whichever method works easiest for you. I personally like method number 2, and that's what you'll be using next year in Algebra 1, but you may use whichever method you like, because both work just fine. Thank you for watching today, and go ahead and head to that next page in your lesson.